This is a presentation of DebtQuest, a visualization tool that lets you explore questionnaire data related to technical debt. Technical debt manifests as symptoms in code. For instance, low quality code and architecture, suboptimal API or framework choices, poor documentation, and so on. However, the causes of technical debt extend beyond code. For instance, expedient or poorly supervised processes, lack of awareness, knowledge, and education about technical debt in your organization, misguided prioritization of issues, and so on. Existing technical debt visualizations are largely tied to code and architectural analysis tools, and these primarily address technical debt symptoms. To address the causes of technical debt, we need to analyze organizational data. And the TD Pulse survey by Antonio Martini was developed for this purpose. It collects organizational data through a questionnaire. But the TD Pulse survey creates a lot of data, and DebtQuest is a visualization tool specifically made to help analyze this data. Now I will give you a demonstration of DebtQuest. So when you open DebtQuest, this is what you're presented with. You need to load a file. So you can load an Excel file that was exported from your survey application, for instance, Google Surveys. And then you will see all the questions along with their unique answers. And now you can do some setup of your visualization and then save it. I will explain more about the features here later. For now, I will just load an already set up version of the survey. And then you open your visualization window. So when you open a new visualization window, this is what you're presented with. You have the survey items, text, you have bar charts showing the distribution of the answers to the survey items, and an association matrix showing the association values between all the survey items. If it's blue or red, it's using a Spearman coefficient for ordinal values. And if it's green, it's using a Kramer V coefficient if one of the items is nominal. And each item has a row consisting of the survey text, the distribution of the answers, and association values between that item and all other items. If you click on a cell, you're presented with a bivariate heat map. And this shows the distribution of all the possible combinations of answers to the two survey items that make up that cell. And this is mainly used to evaluate the association value in the matrix. So for instance, here we can see a very strong negative association, and we want to evaluate it. So I click it, and here we can see that strongly disagreeing or disagreeing in this survey item is associated with empty cell in this item. And why is that? Well, for this question, if you answer strongly disagree or disagree, you're not allowed to answer this question. So obviously this leads to a strong association between not answering or strongly disagreeing or disagreeing to that question and not answering the next question. So it doesn't really mean anything. So we can filter that one out. So that was the item with all the empty cells. We can just filter out. Looking at a cell with strong positive association value, we can see they tend to have sort of like a diagonal, upwards diagonal in the heat map. And if you select a cell with a high negative value tends to have like a negative downwards diagonal in the heat map. Okay, so another thing we can do is we can filter the matrix by p-values. So for every value, for each association value, there's also a p-value calculation. And this, so the coefficient and p-value is calculated using a statistical API for JavaScript. And so now we can, so each of the cells have a p-value. So, and by selecting this, you will blank out all the cells that has a p-value higher than this threshold. So these are two common p-values. And now you can identify statistically significant associations. The main technique in DebtQuest is the parallel sets visualization. And to activate it, you need to select at least 2 items. So let's select what is your role and how much percentage of the development time was spent on technical debt. So we in the parallel sets, each axis represents one item. So this is what is your role, and this is how much percentage of the time was spent on technical debt. And the nodes are the unique answers for each item. And now the links are the combination of answers for those 2 items. So for instance, this will be all developers that report that they spent 15 to 30% of their time on technical debt. Here we have developers who spent 30 to 60% of their time, and 60 to 100%, and 0 to 15%. And this is the same as in the heat map. So if I select the cell that makes up those 2 same items, we can see that these links have, or this combination of answers have been selected here as well. And we can actually use the heat map to make these selections. But the advantage of the parallel sets is the possibility to add more dimensions to the visualization. So if I add one more item now, for instance, what is your experience with software development? And this is in years. And now we can also reorder them. So now we have what is your role, what is your experience with software development, and how much time was spent on technical debt. And if I select a link now, if I select this link, it will select all the links, every path that is possible to take from that link. And if I select a link on this side, it will select only the relevant, or the path that is connected. So you can select like this also. And you can also select on this side to get all the paths that propagate from it, but then you can deselect here. So you can add and remove these paths. And when you select these paths, this number on the node will show the input, the path input relative to the total population in that node. So for instance, now that I have selected all the developers, we can see how they distribute in this. We can see they are relatively more represented in the 0 to 5 years. So in the less experience is more represented. They are least represented in the high experience category. But we can also see that they are more represented in the people who report that they spend 60 to 100% of their time on technical debt. And we can also add more items. So let's add, for instance, we have missed business opportunities. And now we can do something like this. I want to look at all developers with less than 12 years of experience that report more than 30% waste. So I can deselect these. And now we can see how these distribute in the participants that report that there are missed business opportunities because of technical debt. So exploration can lead to very nuanced insights. And also in the heat map, when you have more than 2 axes selected, selecting one cell here will select all the paths going through that combination of answers or nodes. So for instance, if I select developers that report 30 to 60%, we can see that all the developers that report 30 to 60% time spent on technical debt are selected. And so you can, this is a quick way of making these types of selections, if that's something you want to see. And this goes for all the combination of nodes. For instance, here is what is your experience, and we have missed business opportunities. So let's look at people that has 5 to 12 years of experience and agree that there are missed business opportunities. And now we can see they are all selected like this. And we can try with another one. So what is your role and what is your experience? Yeah, so that would be the same as selecting this. Another main technique in DebtQuest is the possibility of adding linked views. So we can bring up a new visualization window. And now these have linked interaction. So if I remove role, for instance, it's removed both sides. And also if I select a path, it's selected in both windows. So the point of the linked view is to be able to compare different subsets of the survey. So we have this set divider where we can select an item that we want to compare. So for instance, what is your role? And now we see we can select the different roles here. So if I select developer and architect here, and on this side I select the product owner, the manager, the tester, and the others. So the non-technical participants on this side. And we can see that the bar charts and the matrix and the parallel sets update accordingly. And we can reorder these items. So for instance, let's put missed business opportunity on top, and then experience, and then the time wasted. And now we can start to compare these, how these demographics align. So for instance, selecting all the participants that agree or strongly agree there are missed business opportunities. Now we can compare these across this item across the axis as well. So for instance, we can see how the developers and architects distribute across the experience and the amount of time they spend on technical debt. We can compare this to how the non-technical people answer. So you can do more nuanced comparisons. And so, for instance, you could select all the people that agree or strongly agree that have less than 12 years of experience. And now you can compare how these distribute across how much time is spent on technical debt. You can compare them across this item. So, for instance, we can see how the developer and architect distributes in this item, or the developers and architects with less than 12 years experience that agree or strongly agree there are missed business opportunities. We can see how they distribute in how much time they spend on technical debt. We can compare that to how the non-technical people that agree there are missed business opportunities, but have less than 12 years experience. We can see how they distribute across this item. Yeah, so you can do very nuanced comparisons with this linked view and the parallel sets. Another main technique in DebtQuest is box plots. So let's select them. And let's select a different set of items as well. So these are: when is my team encouraged to remove technical debt? Whenever we want. When we have extra time, budget, or human resources to be allocated. We have a specific amount of time dedicated to technical debt removal. And when we provide a business case for removing technical debt. And yeah, so we can see there's some empty cells here on top. So let's just filter them out. And so now we can compare the distribution across these items. We can look at the distribution across these items in the developer and architects compared to the non-technical participants. And you can, if you want, you can just click the different set dividers or the set division items to instantly look at the different distributions. You can, of course, select multiple. This lets you concatenate different categories and compare them to each other. So you can do this. You can select this however you can use this however you like. And this works with any attribute. So the set divider could be time frames or company segments or whatever type of demographic the company would like to compare and look for misalignments and so on. Now let's take a look at the settings. So for each item, you can set its type to nominal or ordinal. And this will affect the colors, but also how the association values are calculated. And you can also reorder the answers, which will also affect the association value calculation, but it will also affect how it looks in the visualization. the categories are ordered automatically. So the common values, such as strongly disagree to strongly agree, never to all the time, and so no need to improve to huge improvement needed. But you might need to manually order some of the items. You can filter, let's say, you can filter an entire item and you can also filter an answer for one item, but this will effectively remove all the participants with that answer from the entire survey. A very important feature in DebtQuest is the binning functionality. So we can select any survey item we want. So let's select what is your role. And some companies might have a very high amount of role categories. Some may even let their survey participants answer freely to this question. And so these are all the unique answers given to this question. And as you can see, there are too many to display effectively in the visualization. So what we have here is these bins, 7 bins of generalized roles. And now you can select a bin and you can click a unique value. And so now you are binning it into this category. And this red number here shows the number of people who gave this specific value for that question. So if I perform the binning, we can see it changes in the visualization. And so here's an unused bin. So we can make our own bins. All the bins can be renamed. So for instance, let's call this Chief Architect and place the Chief Architects in there. And so now we have this new bin or new category for that, for this item. And this we can also do with the number values. So for instance, this is how much time was spent on technical debt. And of course, this is a percentage, and they are allowed to answer any number between 0 and 100, integer value. So potentially there are 100 unique answers to this, but people tend to answer the round numbers for these kinds of percentages. So here we can see 5, 10, 15, 20, 25, 30, and so on. These are the most popular values to choose. I have created 2 auto binning algorithms for these kinds of numbers. One is called equally wide bin. So this will bin the unique values into this number of bins that are equally wide. So if I push recalculate now, we can see it creates 3 equally wide bins and all of the values are binned. And so if we see this here, yes. So let's try 3. Yes, so now we have these 3. And we can see that they are equally wide, but they are not equally filled. So I also created this algorithm that divides all the values into 3 equally filled, or as close to equally filled as possible. So recalculate. Yeah, so it's not always super accurate because of some rounding reasons and stuff, but it tries to keep the bins equally filled. But for numbers, I usually end up giving them explicit bin names anyway. So for instance, I tend to use 4 bins, and then I will give them something like this. So 0 to 15, 15 to 30, 30 to 60, 60 to 100. And now I have to manually bin. So because this can be a bit tedious with the number values, I also added this paint feature. So I can just paint the values like this. So it makes it's actually pretty fast to just do this manually. So I rarely use the algorithms. I just do it like this instead. And companies usually have some specific binning numbers they want to use anyway. So for instance, for what is your experience, most companies like to have something like this. So 0 to 5, 5 to 12. So 0 to 5 would be something like a beginner or junior developer. 5 to 12 would be an intermediate. 12 to 20 would be a very experienced developer, and 20 and more would be a incredibly experienced developer. Yes, so that's how the binning works. And that concludes the demonstration. Thank you so much for watching, and if you have any questions, please reach out.